Good morning, dear students, and welcome back to online classes. In lesson 2 in chemistry, we are studying about salts. In the last class, we discussed about two important sodium salts which are part of our daily life, baking soda and washing soda. Today, we will continue with another salts which are of calcium salts. The first one is bleaching powder. We are familiar with the uses of bleaching powder. Bleaching powder is calcium oxychloride, also known as chloride of lime. The chemical formula is CaOCl2. It is a white powder which gives a strong smell of chlorine. It is soluble in water. The small insoluble portion always left behind is the lime present. It reacts with dilute acids to give chlorine gas. Here we can see the reaction of bleaching powder with dilute sulfuric acid. Calcium oxychloride, when reacts with dilute sulfuric acid, gives calcium sulfate, chlorine gas, and water. The chlorine gas produced acts as a bleaching agent due to its oxidizing property. Colored substances turn colorless when oxidized by chlorine. Actually, bleaching powder is an arrangement for storing chlorine. This is because chlorine gas itself is difficult to store and utilize. Preparation of bleaching powder. We know and have studied that chlorine gas is produced during electrolysis of aqueous sodium chloride, which is brine solution. The process is also known as chlor-alkali process. During this process, chlorine gas is produced. This chlorine gas is used for manufacture of bleaching powder. Bleaching powder is produced by the action of chlorine on dry slaked lime, calcium hydroxide. Bleaching powder is manufactured or prepared on a large scale by passing chlorine gas over the dry slaked lime. We can have the representation of the chemical change this way. Calcium hydroxide or slaked lime, when treated with chlorine gas, gives calcium oxychloride, bleaching powder, and water molecule. This bleaching powder is used for various purposes. Bleaching powder is used as a bleaching cotton and linen in textile industry. It is also used for bleaching washed clothes in laundry. The bleaching action of bleaching powder is due to the chlorine released by it. Bleaching wood pulp in paper industry is also possible by bleaching powder. Oxidizing agent in chemical industry. As it gives chlorine gas, chlorine helps in oxidizing substances during chemical changes. Disinfecting drinking water. Bleaching powder is used for disinfecting drinking water supply. This is for making drinking water free from germs. Bleaching powder is also used to manufacture other chemicals such as chloroform, and it is used for making wool unshrinkable in wool industry. The next salt is the salt which is used to make casts. The casting property of POP. Yes, you got it. Plaster of Paris, first observed when a house in Paris built on gypsum burned down. It was found that after rain fell, the footprints in the mud were caked upon drying. POP first used in fracture care by Antonius, that is the Dutch army surgeon, in 1852. The use of plaster of Paris since first observed in Paris, that is why we have the name of the place in its substance name. Plaster of Paris is calcium sulfate hemihydrate or calcium sulfate half hydrate. Chemical formula is CaSO4 dot half H2O. It is commonly known as POP. The raw material for the preparation of plaster of Paris is gypsum. Gypsum, that is calcium sulfate dihydrate. When gypsum is heated, it loses 3/4 of its water of crystallization and forms plaster of Paris. So we can say plaster of Paris can be obtained from heating gypsum to a specific temperature, that is 373 Kelvin or 100 degrees Celsius temperature. The hydration of calcium sulfate hemihydrate converts it from powder form to crystalline form, which gives rise to cast. This is the process of setting and is an exothermic reaction. We can explain it with the particular chemical formula equation. CaSO4 dot H2O, half a molecule, plus 3/4 of water molecule gives calcium sulfate dihydrate. Preparation of plaster of Paris. Heating of gypsum to temperature 373 Kelvin gives plaster of Paris along with water molecule. Calcium sulfate dihydrate on heating gives calcium sulfate hemihydrate and water molecule. Heating of gypsum should be controlled carefully. This is because if gypsum is heated above 373 Kelvin, then all its water of crystallization is eliminated and anhydrous calcium sulfate CaSO4 is formed. This anhydrous calcium sulfate is also known as dead burnt plaster. The dead burnt plaster does not set like POP on adding water. Properties of plaster of Paris. It is a white powder which is ionic compound. It has a property of setting into a hard mass on wetting with water. Due to its hydration to form crystals of gypsum, which set to form a hard solid mass. Plaster of Paris should be stored in a moisture-proof container. The presence of moisture can cause slow setting of plaster of Paris by bringing about its hydration. This will make plaster of Paris useless after some time. Plaster of Paris incorporates 20% of water only it soaks up. The remaining 80% lost during hydration or drying. The time taken to convert from its powder form to crystalline form is known as setting time of plaster of Paris. The average time is 3 to 10 minutes for setting up of plaster of Paris, which can be reduced by high temperature, the salt solution, borax solution, and addition of resins. The setting time can be increased by low temperature and sugar solution. Setting time is 3 times longer at 5 degrees Celsius than at 50 degrees Celsius. Movement of the plaster while it is setting will cause gross weakening. There are many advantages as well as disadvantages with this plaster of Paris to various uses. The advantages are slow setting, infinitely moldable when wet, and cheap. Disadvantages are heavy, messy, significantly weakened if cast is wet, and partially radio opaque. On the basis of advantages and disadvantages of plaster of Paris, the various uses of POP are: it is used in supporting fractured bones in the right position. Plaster of Paris is used in hospitals for setting fractured bones in the right position to ensure correct healing. It keeps the fractured bone straight. This use is based on the fact that when plaster of Paris is mixed with the proper quantity of water and applied around the fractured limb, it sets into a hard mass. This way, it keeps the bone joints in a fixed position. It is also used for making cast in dentistry. Second application is in making toys and material for decoration. Apart from that, cheap ornaments, cosmetics, blackboard chalk, and cast for statues can be made of plaster of Paris. It helps in making smooth surfaces. It is also used as fireproof material and in chemistry laboratories for sealing air gaps in apparatus where airtight arrangement is required. As white in color, it supports the smooth surface before painting at homes or for making ornamental designs on the ceiling of houses and other buildings. So, today we discussed the two salts of calcium, bleaching powder and plaster of Paris. The two have exclusive uses in different ways but in our daily life. One salt is having a fixed number of water molecules to it, whereas another salt is without any fixed water molecules present to it. So we have discussed salt, which is without water of crystallization, bleaching powder, calcium oxychloride, and the salt with fixed number of water molecules, water of crystallization as hydrated salts. About these two, hydrated and anhydrous salt, we will study in our next class. Thank you.